Okay, so you wanted a little help on scientific notation, so here's a few examples. Uh, the general concept behind scientific notation is this number, it's got to look in be in this form. The first number needs to be between 1 and 10. That's very important. If it's 345 times 10 to some power, you're going to have to change it so it's 3.45. If it's 0.0625 or something times 10 to a power, it looks like scientific notation, but this number needs to be between 1 and 10, so you just need to put the decimal here. So it's 6.25 times 10 to a power. So that changes the power over here. We'll get to those kinds of problems in a little bit. Just right now, I'm just going to say convert these numbers into decimals so you understand what they are. So times 10 to the 6 just means move the decimal to the right 6 spots. If it's negative, it's to the left that many spots. So 3.45 to the right 6 times. 1, 2, 3, 4, 5, 6. And fill those spots in with zeros. So my answer will be 3,450,000. And that's it. And the next one, negative x1 just means move it to the left 5 spots. So if I had the 4.2 here, here's the decimal. 1, 2, 3, 4, 5 spots. Put some fillers in. So final answer is 0.00040, a 4 and a 2. That's what it actually equals. That's the decimal notation, or just the number. Now going in the opposite direction, from the decimal to scientific notation. So first number's got to be between 1 and 10. So 2.337. You can stop whenever you see all of the rest zeros. So 2.337, and they use the x for times in scientific notation, times 10 to a power. Well, what's the power? Well, if the decimal's here, so right there, I'm just going to count to the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's positive 10 because it's a huge number. It's a big number. It's not like a very small number like the next one. This one's going to be negative exponents. So I'll just start right here. The only numbers there are 8 and 9, so it's going to be 8.9 to get that number between 1 and 10. So you put the 8.9 and then go times 10 to a power. And then here you count backwards. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. That's a big one. Or a small one. So 8.9 times 10 to the negative 12th. And then this one looks like it's already in scientific notation, but it's not because the first number is not between 1 and 10. So rewrite it as 4.567. So write everything you see, but put the decimal after the first number. And then you're going to have to change this 7 to something else. My suggestion is write this as 10 to the 7th right away. So 4, 5, 6, 7. You can do it in your head too, but and I'll explain how to do that in a second. But 1, 2, 3, 4, 5, 6, 7. So write it as a decimal, and then from that decimal, go back to scientific notation. So there's the decimal. I'll just leave it in that form. Like here's the commas. And then since I want 4.567, I'm going to put the decimal here and count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I had to go times 10. It's a nice fancy color. Times 10 to the ninth there. In my head, I think it's a little easier. So you don't have to write this whole decimal out. For me, it's easier. It might not be at first for you guys. Um, I know the decimal's here. I need to go 7 places somewhere out here. If I'm moving the decimal back a spot, now that doesn't make sense. I screwed up somewhere. This should be a one spot more. So this should be to the 8th power. Let me see where I screwed up here. I wrote my decimal. This is why it's good to double check problems. So we had 4, 5.67 times 10 to the 7th. So 1, 2, 3, 4, 5, 6, 7. Maybe I had too many zeros in here before. Comma, comma. Yeah, I had an extra spot there. And then now when I check from here, 1, 2, 3, 4, 5, 6, 7, 8, that makes sense. Yeah, it is the 8th power. So ignore whatever I said at first. Even though I'm always perfect. Okay, maybe not. The last set of problems. Now, these are the problems you usually see on your homework and stuff. We're going to use the concept. I'm going to clear this and put a new page on here. Something like 6x cubed times 3x to the fourth. Okay. Now this is times everywhere. And I think you understand this. So you would multiply 6 times 3 and then multiply these separately. So this is 18 x to the 7th. Don't put 12, 7. Okay. And that's all we're doing with these scientific notation problems for these. I'm thinking of this as I'm going to group these together, and then I'm going to use my exponent rules for those. Because it says use exponent rules to simplify. You cannot, even if I have a calculator on this part, if this is on a test, you cannot simply type this whole thing in your calculator, type this whole thing in your calculator, get an answer, and then write it in scientific notation. I need to see the work. And the work I'm going to expect to see, I like this color, let's go purple, is multiply these together. So 2.5 sets of 6. So 6 and 6 and 3, basically. So that's 15 times 10 to the, and then add the powers here. 8 plus negative 3 is 5. Okay, so I need to see this step here. And then once I have this, now this isn't, it looks like scientific notation, but this number needs to be between 1 and 10. So it's got to be 1.5 times 10 to a power. If the decimal's here, 5 places to the right, maybe I'll write that out for you. 5 places to the right is 1, 2, 3, 4, 5. So 1,500,000. But I want the decimal here, so it's really 1, 2, 3, 4, 5, 6. So my real answer is 1.5 times 10 to the 6th power. And make sure you show me a little of this work, especially the step right here. Here, 840 times, basically times a fourth, it's times 0.25. So I'd cut it in half is 420, cut that in half is 210. Because half and a half is cut in fourths. And then add the powers, 10 to the negative 8th. Now this looks like scientific notation again, but it's not because that's not between 1 and 10. My final answer is going to be 2.10 or 2.1 times 10 to some power. It's not going to be negative 8. If my decimal's here, that's times 10 to the negative 8th, and I want to move it here to get to the same spot over here. This is how I think in my head. 8 spots here, so to go from here to the same spot, I only have to go 6 spots to the left. Okay, now if you want to write out the decimal, here's the decimal, 8 spots, 1, 2, 3, 4, 5, 6, 7, 8. Fill in zeros. And then rewrite that with the decimal here, 1, 2, 3, 4, 5, only 6 spots to the left. So I'm pretty much doing this in my head when I kind of think these decimals like I did over here. Get rid of that mess. And the last one. Okay, this looks kind of scary probably, but all it is take your calculator, or if it's not on a calculator part, you just have to do this longhand, and divide the numbers, and then use the exponent rules for the powers of 10. Just as if it were x to the negative 5th over x to the negative 3rd. And in scientific notation, they just want you to move everything up to the top, whether it's positive or negative. So x to the 3rd goes on top, and then I'm going to add negative 5 and 3 to get negative 2. Okay. Or you can use a shortcut where you just do 10 to the negative 5 minus, because it's dividing, negative 3. Go for the minus negative. So plus plus, you get negative 2 that way. Either way, you get 10 to the negative 2nd power there. And then when you do 7 divided by 200, we're going to get 0.035. Let me double check that. Yep, that's right. And nice x, nice multiplying. And to make it scientific notation, you need to put the decimal after the 3, so it's between 1 and 10. Very important. And then if I'm moving from here 2 spots to the left, to get to the same spot from here, I go 1, 2, 3, 4 spots. I need to go 2 more spots. Or just write out the decimal. I'm confused here. 1, 2, 3 zeros. Let me double check that. This was what? Negative 2 from 0.035. Yeah, that's right. And then to make this that answer, I want to go from here. So 1, 2, 3, 4 spots to the left. So there we are. Nice and beautiful colors. I think that's all I had for you. Yep, that's it. So, any other questions, stop in and see me. Good luck.